Hello, hello, hello. This is Nicholas on this lovely Wednesday morning, talking to you today about an e-pic integral. Now, you might guess that this involves e, and you'd be right. So, pause the video, give the problem a try, and when you're ready, keep watching the video for the solution. Press toll walker in 3, 2, 1. So, the first thing that I would notice is that, well, I see all these yucky square roots and cube roots and all these things, and so let's deal with those. I like fractional exponents better, so I'm going to work with those. So really what we have is the integral from 0 to 1 of x times the square root of x, which already is x to the 1/2, and this is really x to the 1, times, now we have, it's the cube root of x, but it's also it's the square root of the cube root of x. So it's x to the 1/6 times now x to the, and then we have it's x to the fourth root of x, but then that is being taken, the cube root of it, and then we also have the square root out here. So it's really x to the 1/2 times 1/3 times 1/4. And then likewise, the next one would be x to the 1/2 times 1/3 times 1/4 times 1/5. So on and so forth, dx. So what we really have, if you think about it, is the integral from 0 to 1 of x to the 1/1 factorial, x to the 1/2 factorial, x to the 1/3 factorial, x to the 1/4 factorial, and so on, right? Dx. Now, when we're multiplying the same bases, right, we can make that the integral from 0 to 1 of x to the 1/1 factorial plus 1/2 factorial plus 1/3 factorial plus dx. And now we really have to find a closed form for, well, what is 1/1 factorial plus 1/2 factorial plus 1/3 factorial plus . And now, truthfully, in order to be able to think about what this would be, you kind of have to be familiar with the Taylor series of e to the x, right? So e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus . And now you can see all ones on the numerator, so that would tell you to let x be 1, and so you get e is equal to 1 plus 1 plus 1/2 factorial plus 1/3 factorial plus 1/4 factorial plus . And that means that this whole thing right up here simply becomes e minus 1, right? Because if I bring this 1 over, I have e minus 1 equal to all of that, which is what I want. And so now this just becomes the integral from 0 to 1 of x to the e minus 1 dx. And this is really simple, right? Because now we just integrate. That's x to the e over e, evaluated from 0 to 1. And that's just 1 over e. And with that, we're done.